Hello there, FullSized here with another Rust Electronics video. Today I'm going to be showing you a simple circuit which will allow you to activate and deactivate a SAM site using an RF transmitter. The reason we need this is because at the time of the making of this video, your own SAM site would gladly shoot you out of the air if you were flying a minicopter within its range. The practical application of this circuit would be that when you are going to take off or land or fly a minicopter around your base, you could activate the RF transmitter and turn off the SAM site. And then, once you were away from your base, to protect it from other minicopter pilots trying to land there, you could remotely activate the SAM site. Or, when you land your minicopter at your base, you could again activate the SAM site to protect it from other minicopter pilots invading your space. Also, at the time of the making of this video, the SAM site would fire on any minicopter which was parked within its range that was not touching the ground. Hence, I have made a demonstration heli garage which would work with the SAM site. These helis are touching the ground, and so the SAM site would not shoot at them. If I had foundations in here, and the minicopters were parked on top of them, then once the SAM site was activated, it would start shooting this wall in an attempt to try and destroy the minicopters. It might destroy itself in the process. It might destroy the wall and then blow up the minicopters. Inevitably, it would do a lot of damage to your base, so it's really important to park the minicopters on the ground whenever the SAM site is active. To obtain the RF transmitter, you can buy it from Outpost from one of the vendors for 75 scrap. For today's circuit build, you're going to need a wire, an electric branch, a memory cell, and an RF receiver. Now I've already set up the power with a wind turbine. I also have this electric branch which is set on the branch power to 28 volts. Now you don't strictly need this electrical branch for the circuit. It's simply here to demonstrate the minimum power requirements for the circuit. The reason we need so much power is because the SAM site itself requires a minimum of 25 volts to activate. So now to build the circuit, put down the electrical branch, then the memory cell, and then the RF receiver. Set the frequency on the RF receiver by pointing at it and hitting E. Set it to any frequency you want, so long as you can remember what it is, and hopefully no one else is using it. Now, hold the RF transmitter, and then hold down the right click button. After a second or so, it brings up an interface so you can set the frequency on it. Set it to the same frequency as your RF receiver. Now be careful. If you die with this on you, then someone else will have your frequency, and they might figure out what it does and use it to deactivate your SAM site. So you could change the frequency on your RF transmitter to something else until you're actually ready to use it. And if you die and someone gets a hold of it with the proper frequency, you can simply change the frequency on the receiver to something else before you go out again. So now, hold your wire in your hand and attach to your power output of whatever you're using. Again, this is only here to demonstrate the minimum power requirements. This power input could come straight from your wind generator, or possibly 2 solar panels with a root combiner to get the necessary power. So your power in goes to the bottom of the electrical branch, and then your branch power, which is already set by default to 2 volts, and is exactly what we need for this branch of the circuit, is going to go over to the power input of the RF receiver. The power output of the RF receiver goes to the toggle on the memory cell. Now there are 3 options here: set, reset, and toggle. Be sure you set it to toggle. The others won't work. Now the power out from the electrical branch is going to go to the power in of the memory cell. Now you see the power input here, if you hover over it while holding your wire, is 25 volts. It says the power output is only 24 volts, which would not be enough to activate the SAM site. But it's either bugged in that the memory cell doesn't drop a volt like every other electric device, or it's bugged in that it says the output is 24 volts, but it's actually 25 volts. So don't worry about that. If it says 24 here, you're good. So now take the output from the memory cell and run that to the input on the SAM site. Now you see that the light is red, but as soon as we hit the button, it turns green. You hit the button again, it turns red. So right now the SAM sight is off. You're free to fly around your base. And then once you get away from your base or you land safely on the ground, you hit the button and it turns the SAM sight back on. It's that simple. If you need to, you might want to screenshot right here so that you can follow the wires. Also, if you can see the thumbnail clearly, I've color-coded the wires to make it very clear where each of them is run. Alright, so that does it for today's circuit. However, if you want to hang out for another minute, I'm going to show you another practical application of virtually the same circuit for building a trap base. And if you know me, you know I love my trap bases. So obviously, you would want to hide this solar panel a little bit better. Maybe put it up on the roof or something. But I just wanted to be very clear where all the wires are running. This circuit right here is my improved infinite power circuit, which you can find in one of my other videos. The main point of it is that it's outputting a steady 8 volts, whether it's daytime or nighttime. Because when it's nighttime, it automatically switches over to battery power, which also outputs 8 volts. This circuit does need exactly 8 volts, so that's handy. Over here, we have the electrical branch and the memory cell and the RF receiver, just like we had over there. Everything's hooked up exactly the same, except for the output. The output is going to this electrical branch, and then that output is going to that electrical branch. Then there's an inverted output. Now, these two electrical branches are simply forwarding power to two door controllers, which you'll see in a moment, and then this inverted output is going to a separate door controller. The idea being that two doors can close while one door opens simultaneously when you hit your transmitter. Now I've got this one set to the same frequency, so we can come over here and see how this works. Now ideally, you would be hiding up on that mountain, or you could be in that base way over there with a rifle and a scope looking over here to watch when some helpless victim came along to check out your trap base. So right now, this looks like a decayed base with a previously interior door simply left open. So your victim comes in, they start rummaging through the boxes, which you could put some random items in here to get their attention, and then you see them go in and you hit the button. The loot room door closes, the exterior door closes, and the interior door here opens, revealing these shotgun traps to kill your victim. Now the cool part about this is, 1, they're dead, and 2, if they do have a spawn nearby or a friend nearby who is maybe outside, this door is closed. They can't even get in here to get the loot. You could either wait for the friend to leave, come up and kill them. Maybe there's not a friend, but they respawn and run over here naked to try and get their stuff. They're not getting their stuff back unless they're willing to blow this door up. And then, to reset the trap, just hit the button again, and you're good to go. Alright, well that's the end of this video. Thanks very much for watching. Please like, subscribe, and all that good stuff. And check back soon for more upcoming videos. Thanks for watching, and have a good day.